Today we'll be looking at finding trig function values using a calculator. One thing to make sure of is that your calculator is in degree mode. So again, find that in your settings and switch from radians to degrees if necessary. And besides finding function values using a calculator, we will also be looking at finding angle measures using a calculator. And of course remember that most calculator values for trig functions are going to be approximations. There's a few for special angles that are like 1/2 or 1 or other nice numbers, but other than that, generally they are going to be approximations. So here we'll find approximate values for each of these expressions. Just for simplicity's sake, I'm going to be just rounding to 3 decimal places. Starting off with the sine of 49 degrees 12 minutes. Really no trick to it other than just remember how to find the minutes and degrees on the calculator. Otherwise, when you type that in, you should get 0.756 when we round to 3 decimal places. The second one, the secant for 97.977 degrees. The trick there, of course, is that there is no secant button on your calculator. So you will, of course, have to recall that the secant of theta equals 1 over the cosine of theta. So what we do is 1 over the cosine of 97.977. And that will end up being negative 7.206 approximately for that one. Now for C, the 1 over the cotangent, recall that the tangent of theta equals 1 over the cotan of theta. So this will really just equal the tangent of 51.4283, which we do have on the calculator. And that ends up being about 1.254 when we round to 3 decimal places. And then the last one, the sine of negative 246. Again, we can just type that in as it appears. We end up with 0.914 when we round to 3 decimal places for that one. And if you're having a hard time coming up with these values, again, double check, make sure your calculator is in degree mode. Otherwise, again, just be very careful how you're typing those in. Alright, so when we need to find the measure of an angle having a certain trig function value, the graphing calculator is going to have 3 inverse functions for us to use. So the inverse sine, inverse cosine, and inverse tangent. So if you find the inverse sine of x, assuming that x is in the range for the sine, and that would be from negative 1 to 1, or same for cosine or tangent, then that's going to give you the measure of an angle whose sine, cosine, or tangent is going to give you x. And really for these different functions, you'll find the inverse sine, cosine, and tangent are going to give you kind of different values. But typically we're going to just worry about what's going to happen in quadrant 1 for now, although again, depending on if you're going to be doing negative values, you'll either get a quadrant 2 or quadrant 4 angle as well. And of course, remember, there's really 2 values of theta between 0 and 360 that will give you each of these values also. But for now, we're just going to be worrying about the result between 0 and 90. So for the first one, sine of that number, we just need to type that into the calculator and do the inverse sine of that digit. In this case, the calculator tells me that 75.4 degrees would give me a sine of that value. You can double check pretty quickly by typing that into the calculator as well and verify that yes, sine of 75.4 would give you that. It's a little trickier for the secant. Of course, the secant is the reciprocal of the cosine. So what we would do is we do 1 over the 1.0545829. So actually do 1 over the angle, and we take the inverse cosine of that. Again, so a little bit different there. What we're saying there is, again, secant of theta equals 1 over the cosine of theta. So when we're trying to find the secant, that 1.0545829 would equal 1 over the cosine. Then we'd have to kind of flip the whole thing over and get the cosine equals 1 over this fraction, and so then we would do the inverse cosine of that. So, and that ends up giving you about an 18.5 degree angle. So 18.514 degrees. And again, just an approximation there, of course. So here we have an application problem. So we've got an automobile travels uphill or downhill on a highway. It experiences a force due to gravity. The force F in pounds is called grade resistance, and it's modeled by this equation here. F equals W times the sine of theta. Theta is the grade, W is the weight of the vehicle. If it's moving uphill, then theta is greater than 0. If it's downhill, then theta is less than 0. And this comes from Principles of Highway Engineering and Traffic Analysis, 2nd edition, way back from 1998. So again, actually used in a manual for highway engineering. So we're going to take a look at really 3 different questions. First, we're going to calculate F to the nearest 10 pounds for a 2,500 pound car traveling an uphill grade with theta of 2.5. So we're trying to find F. We know the weight of the car is 2,500 pounds, and the angle of the grade is 2.5 degrees. And so we simply, in this case, type that into the calculator, and we will get we get 109.04 pounds. So to the nearest 10 pounds, call it 110 pounds of force. And it might seem funny to round to the nearest 10 pounds, but again, if you think of it, the 2,500 pound car is probably an approximation in the first place. Plus you got people and things in there, so rounding to the nearest 10 pounds seems appropriate. So 110 pounds of force for that vehicle. For the next problem, we want to calculate F again, this time for a 5,000 pound truck traveling a downhill grade with theta of negative 6.1 degrees. So again, changes a couple of our values. And let's see, negative 6.1 degrees. So again, we type that into the calculator and see what we get. So we come up with negative 531.3 pounds, so approximately negative 530 pounds of force. So negative meaning that's actually pulling the car forward, not, or pushing it forward, not pulling against it. And then for the last one, they just want us to take a look at what happens when theta is 0 and theta is 90, and then see if that makes sense. So really, I think kind of what they're saying is that the poundage would not necessarily make a difference, so let's just go with the 5,000 pound truck. Well, if it's sine of 0, I think the key here, if you look at sine of 0, that is 0. So the force due to the grade there would be 0, compared to if we did 5,000 times the sine of 90 degrees. So if you check sine of 90, that would be 1, so the force would be 5,000. So again, if you're trying to drive your truck straight up in the air, you're going to have to work against the full 5,000 pounds, versus if you are just traveling across flat ground, again, there's no additional force working against the vehicle being pulled down to the ground. Thanks for watching, and hopefully that was helpful.